When I eat something sweet and full of sugar, there's a spike in my CGM, so my continuous glucose monitor. Does the spike mean that something bad is going on in my body?
Kind of, yeah. So I'll go just one step back. There's lots of different categories of foods, but there are two that impact our blood sugar levels. It's starches, so that's bread, rice, pasta, potatoes, oats, and sugars, so anything sweet from an apple pie to an orange juice. These two categories of foods, they're literally made up of glucose molecules. So when you eat them, they break down into individual glucose molecules, and the glucose molecules arrive into your blood. If you eat a lot of starches and sugars at once, a lot of glucose molecules are arriving into your blood. And that's what you see. That's the spike you see on your glucose monitor. Now, these spikes have a few different consequences. You know, having a few spikes here and there is not a big deal, but if you have really big spikes, which I think most of us are discovering we have, even if we don't have diabetes, that's when problems start happening. And there's basically three processes that take place in your body when you spike. It's chronic fatigue of your mitochondria, aging, glycation, and then insulin release. And I can go into detail into these, but these are what underpin all the negative consequences of glucose spikes.
So start with that first one.
Okay.
The mitochondria.
So there's these little factories in your cells that are in charge of making energy. You must have learned this at school. You know, the mitochondria is the factory of the cell. These little mitochondria are constantly trying to make energy for your body. And they turn glucose into energy. So you give them glucose through food, they turn it into energy, and then your brain uses the energy, your heart to pump, your ears to listen, your eyes to see. Your whole body uses this energy. And so you might think, okay, I want lots of energy, so I should give my mitochondria lots of glucose. That's the logical conclusion you might come to. But that's where it completely collapses. See, biology is a bit weird. Take the example of a plant. Do you have any plants at home?
I do, yeah.
Okay. Are you able to keep them alive?
My cleaner does a great job of keeping all of them alive.
I have a super hard time. But the reason I'm bringing up plants is because you know that plants need some water to live. But if you give them too much water, they drown and they die. The human body is kind of the same. Some glucose, amazing, steady energy. Too much glucose, and your little mitochondria start freaking out. They get overwhelmed by too much glucose arriving their way. They kind of go on strike. And I'm French, so I know. But they sort of go on strike, and they get overwhelmed and stressed out, and they're not able to make energy effectively anymore because we're overloading them with too much glucose to process. And as a human, what do you feel? You feel chronic fatigue. You wake up, you're exhausted. Thinking of going to the grocery store or picking up your kids is super tiring. There's this energy system in your body is just kind of broken. But you keep eating carbs, you know, a croissant, some bread, something sweet, but you keep being more and more tired. That's your mitochondria dysfunctioning. So that's the first thing that happens when you spike. You get tired. Your mitochondria get stressed out. And one thing that's interesting is that sometimes when we eat something sweet, especially in the morning, like an orange juice, we kind of feel a sense of like a rush of energy. You know, you have a big glass of orange juice and you sort of perk up for a sec. Most people think that that is energy. What's actually going on is that sugar releases dopamine in the brain. And it's the pleasure molecule. It's the same molecule that gets released when you have sex, when you play video games, when you do illegal drugs. Sugar releases dopamine. It's pleasure. It makes you kind of feel awake, just briefly. But actually, that's not energy because on the inside, your mitochondria are being damaged. So we're being tricked by sugary foods. And when we're tired, we often reach for something sugary to perk us up, but it doesn't work on the inside. So that's the first thing. Your mitochondria gets stressed out. And as your mitochondria get stressed out, they also release what's called free radicals, which is something that increases inflammation in the body. And inflammation is really nasty thing we'll get to in a sec. The second thing that happens when you spike has to do with a chicken cooking in the oven. So if you put, you're looking at me weird, but let me explain. If you put a chicken in the oven, it goes from pink to brown, right? You've seen this, it cooks. This process of cooking is called glycation. It's the process of browning or of cooking. Same thing when you toast a piece of toast, for example. The interesting thing is, a human being, from the moment we're born, we're slowly cooking in that same way on the inside. We're slowly glycating. We're slowly browning. And then when we're fully glycated, when we're fully cooked, we die. That's why when you look at the cartilage of babies, it's white. And if you look at the cartilage of somebody who's 90 years old, it's brown. They've cooked on the inside. And every glucose spike increases, you're looking at your skin.
Yeah, I'm clicking on the outside.
We'd have to like open you up and look at your cartilage color.
I've got about 10 minutes left.
No, Stephen. And every glucose spike increases this process of glycation. So much so that glucose and glycation, they kind of sound like a similar word, glucose glycation. It's because it's glucose doing the glycating. So every glucose spike increases glycation, increases cooking, accelerates aging. And this shows on your skin. You get wrinkles faster if you glycate more. And also on the inside, your organs slowly get damaged. So glucose spikes, mitochondria get tired, you age faster. In response to this, your body knows, Stephen, that a big glucose spike is not good for you. Your body knows that it has to do something to try to get that glucose level down. So what it does, it calls up your pancreas and it's like, yo, pancreas, we got a glucose spike going on. We need to get this glucose down. In response, your pancreas sends a hormone called insulin out in your body. You've heard of insulin before, right? Mm-hmm. And insulin's job, and we love her job is to grab all these excess glucose molecules and to store them away so they don't damage your body anymore. And insulin stores glucose away into your liver, into your muscles, and then when those are full, insulin stores glucose away into your fat cells. And that's one of the ways that you gain fat on your body. It's in response to the spikes and your body trying to protect you from the spikes. The problem is, insulin itself has consequences and is the driver of type 2 diabetes and insulin resistance. So to answer your question, yes, when you see a big spike on your glucose monitor, there's some of that going on. And the more spikes you have, the harder it is going to be for your body to manage your spikes. So it kind of becomes a vicious cycle. If you keep eating the same way, your spikes will get bigger and bigger and bigger and bigger over time with more and more damage.
On that last point about where insulin stores the excess glucose, does that mean that if I have more muscle mass, I'm better at eating sugary products?
Yep. And that's why if you really love cookies, the best time to eat them is right after you work out or right before you work out, because your muscles are really hungry for glucose all the time. And the bigger your muscles are, the more you use them, the more they're going to capture some of that glucose for energy.